Okay, let's tackle that question. The first thing we want to do is simplify it as much as possible. In order to do that, we know the aircraft is flying from point A to point B. So we'll just put a point here and another point here. And we're going to connect those points. Point A here, point B here. Departure time is 8:45. Put 8:45 here as departure time. Distance between A and B is 1,040 nautical miles. Now we're going to get into the details. We know the wind component is -30 headwind, and the calculated ground speed is 240 knots, which means the true airspeed is 240 plus 30 because it's slowing us down, 270 knots. Now that's a very important number here, 240 knots of ground speed. Fuel on board 4,500 minus 700, which is 3,800 available. The thrust calculated is 450 pounds per engine. Specific fuel consumption is 1 pound of fuel per 1.5 thrust. The one engine in operative specific range is 0.45. That's a very important number. 0.45 nautical miles per 1 pound of fuel. The single engine thrust available is 800 pounds. And the specific fuel consumption at single engine is 1 pound of fuel per hour per 1.75 pounds of thrust. So that's also very important. 800 pounds. And we have 1.75 pounds of thrust, which means we'll divide it by 1.75. Calculator. 800 divide by 1.75 equals 457. 457 pounds per hour. Back to this here, 0.45 nautical miles per pound, combining with 457 pounds, will give us the range, which means how many nautical miles we can travel in an hour. So 457 times 0.45 equals, back to the calculator, 0.45 equals 205 knots. We can round it up to 206. Now that's going to be the single engine true airspeed. Very important. It's going to be single engine. Because the point of equal time is single engine back and forth. Now, we have to do some math and calculation.